Okay, so 39, it states 3 to the x squared plus x equals the square root of 3. What should you do first on this? Anybody have a suggestion? What should I do first? Nope. You could. There's a much easier way to do it, though. Lenos.
I set x squared plus x to 1/2.
Why?
Because you know that 3 to the 1/2 equals 3.
Yeah, so if 3 to the x squared plus x equals 3 to the 1/2, then what has to be true?
Then x squared
Has to equal? What's the easiest way to go about solving this? Now we're just at algebra, right? That's it? What's the easiest way to solve this? Anybody have a suggestion?
quadratic.
You can use the quadratic. What could you try first, though? I don't really like fractions either, so I'm going to do 2x squared plus 2x minus 1 is equal to 0. All I did was multiply by 2 and subtract it. Now, can I factor that?
No.
Is anything factorable? Yes. I'll be more specific. Is it nicely factorable?
No.
No, you can check that because you check the discriminant b squared minus 4ac. So that's going to be 4 minus 4 times 2 times negative 1. That's going to be 4 plus 8 is 12. So in this case, the answer is going to be negative 2 plus or minus the square root of 12 all over 4, which is negative 2 plus or minus 4, sorry, 2 root 3 over 4. So you end up with negative 1 plus or minus root 3 all over 2. So are there two answers to this? Yeah, there's two. There it is. You have to use the quadratic formula. There's no nice way to factor it. Okay, another one from that first group. Another one from that first group. You run any walls in the first group? Yes.
Wait,
what number?
I was wondering, what does it mean to using graph that is
Which one?
50.
50. Let's try number 50. Good. 2 to the x times 5 equals 10 to the x. What should I do first? Here's a tricky one. What should I do first? What's 10? What is 10? Yeah, so this is 2 to the x times 5 equals 2 times 5 to the... What do I do with the power outside right here? Where do I put it? Yeah, I can essentially distribute it in so it equals what? 2 to the times? What can I cancel on both sides? What are you left with? 5 to the first is 5 to the x. So what does x equal? Yep. There it is. It's really easy to do that one wrong and get the right answer. Any others from the first group? Any others from the first group of questions? We're pretty good with those? Okay. 125,000 divided by that. Bingo. Very good. So let's just discuss where did people go wrong? What are different things people did wrong? Yeah? Wrong equation. So problems people had. Wrong equation. What else? Anything else?
Minus 1 rather than plus 1.
Oh, just small mistakes in the equation? Is that what you mean?
Yeah.
One common mistake here is n is the number of payments plus 1. Usually it's written as n plus 1.
I thought it n is minus 1.
Ah, you went two payments. The number was 119.
It's 119, yeah.
Yeah, use 119 out of 121. Yeah, that's a way to get really frustrated because is your answer going to be kind of right? What did you got 157, right?
Yeah.
That right there that's close. This is called an annoying answer, right? Because when you get something like this, you're like, yeah, that can't work, right? You're like, he just saved $600,000. Good for him, right? But this is hard. Finding errors like that are harder to find, I think, because you're close. Sometimes it's a rounding error and you don't know where. Sometimes it can be really, really annoying. Absolutely. Good. So yeah, you got that right there. Very nice. Yay. Very good.
Wait, I still have just got one thing.
Yep.
Is Dorian a boy's name?
Yeah.
Really?
Dorian. Yeah.
I didn't know Dorian was.
It's actually a name of someone I actually met in real life once. Okay, first of all, can you tell me, does it have a horizontal or an oblique asymptote?
Yeah.
Yes, it has one of them. That's right, it does not have an oblique. It has a horizontal. What is the horizontal asymptote?
0.
No.
Wow.
No. Y equals 0. a number is not an asymptote. You have to say y equals 0. It's the equivalent of having really, really, really terrible language skills to say the asymptote is 0. Okay? So the horizontal asymptote is y equals 0 because what's the degree of the denominator? 3. What's the degree of the numerator? 1. The degree of the denominator is greater than the degree of the numerator, so therefore the horizontal asymptote has to be y equals 0. Y equals 0. Okay, vertical asymptote. How do you find that? What do you have to do first? Even before that, what should you do? Factor the denominator. What can you first pull out? X times 1 minus
X squared.
and then what does that factor in? X times what?
1 plus X.
Times?
1 minus X.
Yes, that's correct.
There's 3 good ones.
So now you have f of x is equal to x minus 1 over x times 1 plus x times 1 minus x. Okay, so what do we think the vertical asymptotes are?
X equals 0.
Yep.
X equals negative 1. X equals 1.
Well, let's test it out. Let's see what this looks like. Y equals, what was it? It was x minus 1 on top?
Yeah.
Divided by what?
X. 1 plus X.
X minus x to the what? Third, right? Like that? Let's zoom standard. See what happens. How many asymptotes? Oh, and then I still had that line in there. I'm sorry. That was the asymptote from yesterday. Remember the oblique? Hold on one sec. We're going to graph it, and then I'll let you ask your questions. How many vertical asymptotes do you see?
At least 2.
Well, let's go from negative 5 to 5 and see if you can see it. How many vertical asymptotes do you see now? 3? Really?
2.
I see 2. I see 2. Let's take a look at this graph. We thought the vertical asymptotes were at... why? There is something that cancels. You have to do a little more algebra. So look, what do you have right there? You have x equals negative 1 and you have x equals 0. Which one is not there? There's a problem with this one, right? Well, look, why is that true? What? What do you have to do first in order to cancel it out? Factor out a negative from the top. What does it become? Negative what? Negative x plus 1, right? Over the same thing, but what is that? That's negative 1 minus x over x times 1 plus x times 1 minus x. So what cancels? 1 minus x does cancel. So this actually is a removable discontinuity. No, we canceled from the original. We canceled it out. So, oh, sorry, not negative 1. You're right. I'm sorry. I circled the wrong one. I'm sorry. Yes, I'm sorry. This one. That matches our graph. You're absolutely right. I'm sorry. I circled the wrong one. Does that make sense, everybody? So you got to finish the algebra in order to get the proper answer. So there are 3 asymptotes: y equals 0, horizontal, x equals 0, and x equals negative 1, vertical. Does that make sense? So in this one right here, there are no asymptotes because the degree on top is 2 greater than the degree on the bottom, which means there's no horizontal or oblique asymptotes. And then we looked at the denominator. Is there anything that makes the denominator 0? No, there's nothing, no real numbers, because the discriminant is negative. Because it's negative, there are no real solutions that make the denominator 0. So there's no vertical asymptote, so no vertical, no horizontal, no oblique. Are there any asymptotes that you know of? No. The only asymptote you can think of this having is it does have a curved asymptote, but we define asymptotes as being lines. So there are no straight asymptotes, so therefore there are no asymptotes for our purposes.
Would that be...
So how do we do this? Sorry, we missed something. You're right, the first thing is x squared, but we have to multiply times all 3 things. So what's it going to be? X to the 4th minus x cubed plus what?
X squared.
Now we subtract, and what do we end up with? X cubed minus, or plus what? X squared. 2x squared minus x squared is x squared. So what's leading now?
X.
It's still plus x. X times that is x cubed minus x squared plus what? Subtract, and what do you get?
2x squared.
Yep.
Negative minus x plus
Now, this is where it's different. Plus what? 2. So 2x squared minus what? Plus what? Subtract, and what do you end up with? Minus. Now, do we go any further? So it's going to be plus x minus 1 over x squared minus x plus 1. So in this case, we're going to call this our, ready? I'm going to write this for the first time ever in class. That's not a, we're going to call this a parabolic asymptote. X squared plus x plus 2. Let's graph that and see what it looks like. X squared plus x plus 2. Look at this. Does it almost completely overlap? Ready? Let's zoom out. So here's the first function. Where's the second function? It's so close, it's on top of it. Zoom in. There's the original function. And here's the function that it is mirroring. Ready? So is it really, really close to that? Yeah. So it gets very, very close. Okay.
Yeah,
Nice.